Hello, ladies and gentlemen. Welcome back. Let's go ahead and look at Chapter P, What is Statistics? So I do want you to take some notes here. Remember, if I go too fast, you can pause it. You can rewind it and watch it again if you need to. But take good notes. These notes are for you, okay? Don't just write them down and set them aside and never look at them again, all right? So take the notes the best way that is useful for you. All right, let's go ahead and get started. Before we jump into Chapter P, we're going to talk about, remember how I talked about in the intro about three big ideas? Well, that first big idea is exploring data, okay? So in Unit 1, we're going to explore one variable data. Now, that covers about 15 to 23% of the curriculum required for the AP Stats test. So I'll be going over those different percentages as we go through the year. All right, so what is that? What is exploring one variable data? Well, we're going to interpret univariate graphical displays. Now, univariate, uni means, remember, one. So what are some things that we're going to do? Well, constructing and interpreting graphical displays. We have dot plots, stem plots, histograms, cumulative frequency plots, okay? If you're not familiar with those, I'll talk about those, and you're going to find those in the textbook. And also remember, and I'm going to point this out, ladies and gentlemen, Khan Academy, you all have Khan Academy accounts, has a lot of beautiful stuff for AP Stats. So I want you to use that as a supplement to this class. And I'll talk more about that as we go. All right, so what are we going to look at? We're going to look at the center and spread. Where's the center of the data? How spread out is the data? We're going to look at clusters and gaps, okay? Like clusters, there might be a cluster of data over here, and then there's a gap, and then there's a cluster of data down here, okay? And then we're going to also investigate, well, why is that maybe, all right? Outliers and other unusual features, okay? Hopefully you remember what outliers are. Okay, it's a data point or data points that don't fit in the normal range of the regular data. And we're going to look at the shape. Is it normal? Okay, ooh, normal curves. Can't wait to get to that. Is it normal? Is it skewed to the left? Is it skewed to the right? Etc. All right, let's keep going here. All right, we're going to compare distributions. Okay, we're going to compare dot plots. We're going to compare back-to-back stem plots. We're going to compare parallel box plots. We're going to look at displays where we're going to be able to compare them. When we compare them, what are we going to look at? Well, it's almost like the same thing we just saw. We're going to compare the center. We're going to compare the spread. We're going to compare the clusters. We're going to compare gaps. Outliers. We're going to compare the shapes. All of these things tell us something about the data. Remember, the data is telling us something, and I'm going to teach you how, hopefully, to interpret it, but you have to know how to read it, okay? All right, let's keep going. We're going to also summarize it, okay? We do write in this class. It's not all math, okay? There is some writing to do. It's like formal writing. We're gonna have a certain format. That's not till, February. There's a way to formally write out a situation with a hypothesis test. In fact, right now, you're going to learn all about the stuff, with the COVID going on and all the research and the blind testing and the trials and all of that stuff. Okay, we're going to be talking about all of that. This is real life application mathematics here, this AP Stats. All right. When we summarize the data, we're going to look at the median, the mean, the center. We're going to look at the spread, and spread, there's different things for spread. There's the range. There's the interquartile range, also known as IQR, and there's the standard deviation. Standard deviation is huge. Okay, you're going to get to know standard deviation like the back of your hand. All right. Measuring position. Quartiles, remember the box and whisker plots? Quartiles. Percentiles, Standardized scores, z-scores. If you just took advanced algebra last year, that's the last thing we were doing. All right. Outliers and other unusual features. A lot of the outliers we discuss in scatter plots, chapter 3. The effect of changing units on summary measures. Okay, if you change the units, how does that affect it? How will that affect the measurements? All right, let's get started. So if you recall, the book begins with a case study. All right, let me pull this in. So here's chapter P on Schoology. Let me go ahead and pull up the book. Here it is. All right. And in this case study, we are talking about, can magnets help reduce pain? All right. So I want you to read through that summary. You can pause it now if you want. I don't know how big it is on your screen. You can read it now or you can read it later, but I'm not going to take the time to read through that. And then remember, at the end of the chapter, you're going to be able to answer some questions about that. All right, so let us go back to this. All right, so that will be the case study on magnets. All right, I'd like to throw a few of these in. These are also in your book. Okay, little comic strip here. You know, Fred, stats say anything you want. People get away with murdering statistics, or with murder using statistics. You're going to have to use something a little more reliable than statistics say. Rumor has it, that's better. All right, just a little comic there. All right, so keywords: statistic, population, sample. Now, I'm not going to write those definitions down. You can take time to do this on your own because it's in your book. All right, so let me pull that back up. So on page 6, you can find the word statistic. Statistic is the science and art of learning from data. All right, there's statistic. Let's go back to this. Population. Okay, well, you've talked about population before, ladies and gentlemen. All right, what is the population? How can we draw conclusions about a large population? All right, well, remember, population involves everybody. The population of Columbia Heights High School would be all of the students. If we're talking about the city of Columbia Heights, it's everybody that lives in Columbia Heights. Okay, so population is everybody. Okay, you already knew that though, right? Yes, you did. Sample. Okay, well, you know what a sample is. A sample is a part of the population. Part of the population. Okay, for example, if a sample of the high school students would be my AP Stats class. Okay, so you would be a sample out of the whole population. All right, I think you know some of these words, but write them down, make sure you know them. Let's keep going. There are cautions in the book as you read it. Remember, I want you to read that book. This first caution: data beat personal experiences. Okay, data always beat personal experiences. Okay, just because your best friend experienced something and thinks that's the way it is, that doesn't necessarily mean it is. Okay, data will always beat personal experiences. So just remember that. You will see in your book, there's a neat website you can go to, the National Center of Educational Statistics. This looks a little old, but it is still there. It's just filled with all kinds of data that you could evaluate or look at if you're interested in things. All right, next, available data. What is available data? Data that were produced in the past for some other purpose, but that may help answer a present question. Well, right now, the United States is gathering all kinds of data. The census. Hopefully your family filled that out. All right, the census tells the government what programs we need, et cetera, et cetera. That's why it's so important to fill out that census. Okay, so that census information will become available data. Okay, we could look at the last census data if we really wanted to. It's out there. And that's what this website is also showing. That's available data. All right, surveys. Okay, you know what a survey is, right? Okay, again, you're going to find this in your book. Okay, a survey, if you wanted to take you wanted to give a survey at school, would you ask everybody? No, you don't want to do a survey. You wouldn't call it a survey if it was everybody in the school. Okay, that would be a census. A census is encompassing all of the population. A survey is only for part of the population. Caution. Make sure you know where the data come from. That is very important. Okay, I always ask, where did that come from? Who did that study? All right, let's keep going. We have observational study versus experiment. In an observational study, we observe individuals and measure variables of an interest, but do not attempt to influence the responses. We're only observing. In an experiment, we deliberately do something to individuals in order to observe their response. Okay, very important to remember that. We will talk about experimental design in I believe it's chapter 5. Okay, experiment. You deliberately do something. A treatment is imposed. All right, moving on. Remember, you can pause at any time. All right, another little comic here. There they are again, the 5 most terrifying words in TV news, according to a new study. Boy, isn't that true now even? All right, the importance of data integrity. All right, you'll find this in your book. I want you to read it. You're going to see that little symbol. I want you to read over that. All right, data analysis. Individuals and variables. Remember, individuals are the objects described by a set of data. Individuals, they might be people, but they could also be animals or things. A variable, okay, don't think algebra here. Okay, we're not going to go, oh, the variable is y. The variable is, no. A variable in this situation is a characteristic. A variable can take different values for different individuals, like eye color. That's a variable. That's a characteristic of an individual. Left-handed or right-handed, male or female. And when we look at stuff, ladies and gentlemen, we need to keep these things in mind. Who's in this data? What's the data about? Why was this data collected? For what reason? Why? When, where, how, and by whom was this data collected by? All right? If McDonald's wanted to do a survey and they did the survey in their stores, I wonder what the results of those surveys, how those results would turn out. That's what, who gave it? For what reason? Why did they give it? Okay, keep all of those things in mind. All right, 2 types of variables. We've got categorical and we have quantitative. Okay, categorical places an individual into one of several groups or categories. Okay, eye color is categorical. Left-handed or right-handed is categorical. Quantitative is numerical values for with arithmetic operations such as adding and averaging make sense. Okay, how tall are you? That's a number. It's arithmetic. What's your shoe size? Okay, that's quantitative. Quantitative deals with numbers. Categorical deals with groups. All right, moving on. Distribution. The distribution of a variable tells us what values the variable takes and how often it takes these values. Okay, the distribution, like The distribution, if you did a survey, what's the distribution of age, of the age of the people you took the survey for? Okay, tells us what values the variable takes and how often it takes these values. Okay, that was just a minor example of that. Exploratory data analysis. Begin by examining each variable by itself. Then move on to study relationships among variables. Begin with graph or graphs. Okay, you should always begin with a visual display. Begin with a graph or graphs. Then add numerical summaries of specific aspects of the data. Center, spread. Okay. I can't think of the other things right now, but that's what you need to do when you're exploring data. All right, look at this data. Cool, total, 6,122. Total what? Oh, let's take a closer look at it. Let's see, it was founded in 1802. The altitude is 620 and the population is 3,700. What? Okay, wait a minute. They just added those numbers together and they have nothing to do with each other. Okay. Analyze it very carefully. All right, what is it telling us? All right, let's talk a bit about bar graphs. Okay, bar graphs, also known as a bar chart, is a graphical display of data using bars or different heights. Okay, you should know that. Here's an example of one. Again, these are in your book, ladies and gentlemen. Again, look through your book, read. All right, so we've got relative frequency on the side. Please make note, relative frequency is a percent. Okay, percents, relative frequency is percents. And in this picture that you're looking at, I believe it's coming from an example in your book. Bar graphs are made from categorical data. And you'll notice there is space between each bar. Categorical data, you generally leave space between each bar. All right? Now, how do you find relative frequency? Remember, relative frequency was is a percent. You could also leave it as a decimal. Okay? You take the number of successes and divide it by the total number of trials. So again, it could be a percent, or it could be the decimal equivalent of that percent. Frequency. If you just see the word frequency, it's really important. Words have meaning. And in AP Stats, if you get the meanings of words mixed up, it makes a huge difference in interpretation. All right? So if you just see the word frequency, that's the rate at which something occurs, the actual count. Like I gave a survey and 40 out of 50 people preferred Coke over Pepsi. 40 is the frequency. 40 out of 50, okay, 0.8 or 80% is the relative frequency. So don't get relative frequency and frequency mixed up. Okay, sometimes you might have a side-by-side bar graph. Okay, in this one we can compare. You can see that the blue was for wearing seatbelts versus 1998 versus 2003. So on the side we've got our percent. You can compare the seatbelt usage, and then the different regions was in the United States. Again, this is in your book. You can look at that a little bit more in detail. Also, I want you to look at example 7. Okay, example 7 is talking about a dot plot, probably the simplest plot you could ever make. Okay, you're going to put your numbers down below. Okay, you could also do this with categories, I guess. And then you just simply put a dot for each data point. Okay, it kind of looks like a bar graph or a histogram, which we'll talk about in a little bit, but it's showing each individual data point. Okay, let me repeat that. This is a detail you need to remember. A dot plot is very detailed because it shows each individual data point. All right, remember that. Caution, many relationships between two variables are influenced by other variables lurking in the background. Ooh, we call those lurking variables. Other things are influencing something. but we may not know what those are. Oh, those are called lurking variables. We'll talk about those in more detail later. All right, here's another double bar graph. This one is dealing with Alaska Airlines and America West. Okay, example 8, go ahead and look at that. And down below you can see the different cities, so this is categorical. Here we have this is problem 11 from your book, and I believe you're going to do problem 11. You can see the information given it to you in a spreadsheet. We've got gender, left-handed or right-handed, the height, homework time, what type of music they like, how many coins in pocket. Not quite sure, I don't quite remember what that is, but there's some data given to you, and you're going to answer some questions in it. Another thing, what is statistics? Is probability. Okay, what are the chances? So there's quite a bit of stuff that we have to know about probability before we can get into the formal inference statistics at the end of the year. So we're going to have to work with probability. Okay, and you know that if you flip a coin many times, this is flipping a coin many times. Okay, this was the first flip. And then we flipped it again and again and again and again and again. We just kept flipping that coin over and over and over and over again. And eventually, ladies and gentlemen, it levels out. It flattens out. Okay, that's very important to understand in probability. Okay, remember, chance behavior is unpredictable. Okay, so at the beginning, ladies and gentlemen, it's very unpredictable. Okay, however, in the short run, it's very unpredictable. But if you keep going as a regular and there is a regular and predictable pattern in the long run. So I know that if I keep flipping a fair coin, eventually it's going to end up at about 0.5. 50% heads, 50% tails. But in the short run, it's very unpredictable. All right, let's move on. All right. Statistical inference, this is the third thing that we're going to be talking about. Again, that's going to be around February, somewhere in there, March. Drawing conclusions from data. So first we have to learn how to read the data, understand the data, okay? Graphs, numbers. Then we need to understand probability and chance. And once we have those down, then we can use them to help draw conclusions from data. The theory, method, and practice of forming judgments about the parameters of a population and the reliability of statistical relationships, typically on the basis of random sampling. Caution, because variation is everywhere, we cannot be certain about our conclusions. We have evidence to suggest something, okay? Evidence to suggest, but that doesn't mean it might, okay? However, statistics help us better understand variation so that we can make reasonable conclusions. Okay, reasonable conclusions. Oh, I love this stuff. All right, so case closed, ladies and gentlemen. Here is a little picture of the frequency of that, the magnets. Hopefully you're able to read it. If not, we'll talk about it in class. All right, now this, ladies and gentlemen, if you don't know, this one is formally known as a histogram, not a bar graph. Histogram. A histogram is numerical on the bottom. A bar graph is categorical. All right. And ladies and gentlemen, that was it. All right, again, rewind if you need to, rewatch it if you need to. Hopefully that was informative of what is statistics. All right, again, I expect you to read that book. Until next time.